Sorry ass DJ.
My name is Roger Mendoza Hipolito from BSc 1C. The subject is Physics for Engineers. The topic is all about free-falling bodies. Free fall defined as the motion of an object subject only to the influence of gravity. That is to say that any object that is moving and being acted upon only by the force of gravity is said to be. In a state of free fall, the value of acceleration is 9.81 meter per second squared. If the object is downward, the acceleration value is positive 9.81 meter per second squared. And if the object upward, then definitely it is directly opposite to the gravity. So, the acceleration value is negative 9.81 meter per second squared. In these free-falling bodies, we're going to use the value of gravity, which is 9.81 meter per second squared. Here a sample problem. A fruit drops from a tree and falls to the ground 3.15 meter below. So, we have a figure here to visualize the problem. This is the fruit when it fell to the ground. And y sub o is equals to 0 because this is the origin. The direction is downward, which is positive. And the acceleration due to the gravity, which is 9.81 meter per second squared. From here to here, y is equal to 3.15 meter. And this is the height of fruit when it falls. For letter A, how much time does it take for the fruit to reach the ground? For letter A, we use the equation which is y is equal to y sub o plus b sub o t plus 1/2 and g, or the acceleration due to the gravity, times t squared. For letter B, we use the equation of b is equal to b sub o t g, or the acceleration due to the gravity, times t. So, let's start with letter A. Y sub o is equals to 0. So, cancel. B sub o is equals to 0, which is the initial velocity. So, cancel. So, we have y to 1/2 g times t squared. So, we cross multiply. So, 2y is equals to g times t squared, and divide both sides by g to cancel g. So remaining is t. Transfer t squared to here is equals to 2y over g. So we have to take the root to cancel the square. So now t is equals to square root of 2y over g, and by substituting the values, t is to square root of 2 times 3.15 meter, or the height of fruit, over 9.81 meter per second, and cancel the meter. So now we have 0.801 seconds. So this is the time that fruit needed to reach the ground. For letter B, what is the fruit's speed just before it hits the ground? So we already know the time, which is 0.801 seconds. So we can solve the B. The initial velocity is 0, so we can cancel this. Now, B is equals to 9.81 meter per second squared, or the gravity, times 0.801 seconds.
Go.
So we cancel seconds and the remaining is meter. So P is equals to 7.86 meter. So this is the velocity using this equation.